Hi everyone, hope you are still well. This is the last question for this section that we'll be going through. Okay, so now let's read the question together. So for part 1, we have to express 3 to the power of x times 2 to the power of 2x equals to 7 to the power of 5x. Okay, basically it's the equation in the form a to the power of x equals to b. So let's study this final form that they want us to express in carefully. So basically, right, on our left is a to the power of x. Okay, a to the power of x, meaning we need to have something to the power of x on the left. But on our right is different. There shouldn't be any x involved. Okay, they say that a and b are constant. So b is just a constant. It's just a simple number. There's no x involved over here. Okay, then after that we have to use this, right, to solve the part 2's question because they said hence solve the equation. But let's worry about that later. Let's do part 1 together first. Okay, so for part 1, we have to express 3 to the power of x, 2 to the power of 2x as something. Let's just look at this first. Okay, so first of all, if we want to simplify the left, that means we want to express the left hand side of the equation as a single something to the power of something, right? This definitely will work because for our indices law, we know that we have a few. So basically, we have things like a to the power of m times a to the power of n is equals to a to the power of m plus n. But realize that actually this works only when you have the base are the same. Here we have a 3 and a 2, so this thing won't work. Okay, this thing will work. So here what would work? Let's see. Let's have this. This also won't work because this just tells you that if I have a to the power of m to power something, then this will be a to the power of m. Again, won't work. What else? What else? Let's see. We also have this a to the power of m, a to the power of n. What happens here? Okay, a to the power of n. What's wrong? Sorry, give me a moment. Okay, let's just keep that line. Let's just go further. So let's say if I have a to the power of m times b to the power of n. I know that because they have the same power, right, I can express it as ab, the whole thing, to the power of n. So this seems the most closest. This seems the closest to our form over here. But the problem is they must have the same power. Here I have 3 to the power of x, here I have 2 to the power of 2x, which have different powers. So let's see, what can we do? We can actually express this as something to the power of x. So that's my ultimate aim. I want this 2 to the power of 2x to be something to the power of x. But how can I do that? I can actually do that using things like this. Because I know that a to the power of m raised to the power of n is equal to a to the power of mn. So the powers, right, I can actually split it up to become 2 to the power of 2 over here. 2 to the power of 2. Let's check whether these and these are the same or not. So 2 to the power of 2 to the power of x, using this law will give us back 2 to the power of 2x, which coincides with this. So it's good. So let's just copy the right hand side down because I also don't know what to do with it at the moment. So here is 4 to the power of x. So now we can apply this in this law already. Because here, right, I have something to the power of x, here something to the power of x, both the same power, so I know that this is 3 times 4 to the power of x is equal to 7 times 5 to the power of x. So here is 12 to the power of x is equal to 7 times 5 to the power of x. Okay, so at this point, right, let's take a break. Let's just look back at our original question to see where we want to go. Okay, eventually we want to get to a to the power of x equals to b. The right hand side is a constant, it's a b. There's no to the power of x over here. So looking at our current situation, says that this thing shouldn't be on this side of the equation at all. Okay, because I only want a constant. So here this 5 to the power of x, right? Let's move it over to the other side. Let's move it over. And by moving to the other side, right, it's just our simple algebraic manipulation. It's going to be a divide 12 to the power of x divided by 5 to the power of x, and this will give us 7. And what is this? This will simply be 12 over 5 to the power of x, because again, using indices law, again, so if we have a to the power of n over b to the power of n, this will be a over b to the power of n. Okay, so we are done because this is the form that they want. Our a, right, is our 12 over 5, whereas our b is our 7. Okay, we are done for part 1. Now let's move on to part 2. Okay, we have to solve the equation for x. So we have to solve the equation. The equation they are referring to is this, the original equation. But because of our good work in our part 1, we can actually express this equation in its equivalent form, which is 12 over 5 of x is equal to 7. This is from part 1. Okay, and then from here, right, again, we can use logarithms to help us, because now we can take log on both sides. So take log on both sides. What's the purpose of doing this? Let's see first. So this would be 12 over 5 to the power of x. This will be log 7. Okay, don't forget that you have to take on both sides. On both sides. Don't just take on one side. Let me just continue over here. Okay, what's the purpose of taking log, right? It's because now with the log in place, I can make use of the power law to bring down the x. So this becomes x log 12 over 5, and the right hand side remains the same. So now our x is brought down already. So now we can just calculate what is this using our calculator. Okay, the answer that you should get is 2.22. Okay, the calculator. So this is correct to 3SF. Okay, so that's all for this section. Take care of your health, drink more water, and study well. Take care.